Okay, we are still with the same problem, the Walton's bookstore. Now, what if we want to run this simulation for different order quantities? See, in the previous example, we assumed a constant order quantity of 200. What if we want to try different values for the order quantity? Okay, so that's the extension that we're going to look at here. And for that, you select the cell and we insert a function which is under special. You see there is something called risk sim table. Risk sim table lets us run the simulation a number of times using different values for input in that particular cell. So if you click risk sim table, so it gives a default values, but we want these values to be used. So select these cells and click OK. See, now this cell has this function risk sim table D9 through H9 with the value of D9 being displayed. So this is our decision cell. So let's color code this to that. Okay. So now when we run the simulation, then we want it to run X number of replications, say 1000 replications. The first simulation with 150, so simulation number 1 will use 150. And simulation number 2 will use 175 as the order quantity. Simulation number 3 will use 200, 4 will use 225, and 5 will use 250. And we can then gather summary statistics for each of those simulation numbers, and we know that these simulation numbers will correspond with these as the order quantities. Okay, let's now set up the model itself. So the model is exactly the same as in the previous case. So everything else will be the same. So the demand will be from triangular distribution, and the profit is going to be our output cell. So I'm going to name the cells now. Okay, so the demand, remember, is going to be the triangular distribution. So we define distribution, we select triangular distribution, okay, and then we click that cell, which will open up the window for identifying the cell references for the parameters. Click that button and we are done. Well, except that we have to make it into an integer, and for that we'll use the round function around it. Okay, and sales will be the minimum of order quantity and demand. Return will be order quantity minus sales. Revenue is sales times unit price. Cost is order quantity times unit cost. Refund is returns times unit refund. And profit is revenue minus cost plus refund. Now we have to specify profit as our output cell. So select that cell, and now we have to click add output, and the name of the output cell is profit. So there it is. So now we need to set up the summary statistics functions for each of the different simulation runs. So this one is profit. All right. So the order quantities corresponding with each of these simulation runs are these. So we can just simply display those order quantity values here, and I'm going to simply type in the functions instead of clicking and entering. Risk min profit, comma, the simulation run number. So that will come from the first run. So when I copy this function across, B16 will change to C16, which is 2, and in this column then we will get the summary statistics from the second simulation run, which would use 175 as the order quantity. So this is risk max, profit, and simulation number. Okay, and then risk mean, profit, and the simulation number. Risk standard deviation, profit, and the number. Risk percentile, profit, okay. Now I have to specify the percentile number, which is 0.05, and simulation run. Okay, then risk percentile, profit. Now we want 95%, so 0.95, and the simulation number. And then risk target is what we have to use here. Risk target, profit, 300, and the simulation number. That's your cumulative probability. And for greater than 400, then we have to do 1 minus risk target profit 400 and the simulation run number. Okay. So now when we copy these, okay, all of these will be profit, but when we copy this to the next column, B16 will change to C16, and that would represent the simulation number 2. Okay, all of this will be populated properly once we run the simulation. Okay, so right now you get the error message $n/A. Okay, so now we have set up the model. Now let's look at the settings. So here we want 1000 replications. So let's change that to 1000. And here there are 5 simulations, okay, which are these 5 simulations. Okay, now we can run the simulation, but since this is an academic version of the software, it's going to give you, at risk will give you an error message that this is an academic version. You cannot run more than 1000 replications in auto run. So you have to click OK 5 times and then you'll be fine. Okay, so I'm going to click start simulation. Okay, so here's the error message I was talking about. So it's running. Okay, you can see the progress of the simulation. So the first simulation has run. Now click OK. Now the second one has run. Third, fourth, and then the fifth, and you have the results. Now the summary is also given here, and we can select the simulation for which we want to see the graph, and that would be okay. So here is the simulation number. So if you click here, you can select the particular simulation run that you want. So you want simulation number 4, so you can select, okay, simulation number 4 will appear. So this is all the simulations combined. Okay, now let's close that. Now let's look at the summary output that we have gathered. So these are currencies, so you can see what happens in each of those cases. So these are probabilities, and we can tell the probability of making at least $400 profit is maximized in this simulation run where the order quantity is 175. Now if you've closed the at-risk output, you can go back to at-risk and then you can select one of these buttons and that will show you the results back again. Okay, so that button will open the browse results window again, and we can look at the simulation results one by one if you like, and so on. So this is this gives you a fairly basic idea about how to run at risk, and the as you see that it is really very simple, and you have to just a couple of buttons here and then you're okay. Now we can define any number of probability distributions simply by selecting the distribution that you want, and you can also gather all kinds of output in a very easy and quick way.